Good morning, class. We are looking at Module 3, covering Chapters 5 and 6 of College Algebra, Chapter 5, Polynomial and Rational Functions, Chapter 6, Exponential and Logarithmic Functions, and here's Chapter 5, Polynomial and Rational Functions. The price-demand function of a company that manufactures tops is P of x equals minus 5x plus 600. Find the revenue function. As you know, revenue by definition is the number of units times the price. So number of units that we sell is X times the price, and their product will be simply minus 5x squared plus 600x. So that would be the revenue function. The company's fixed monthly cost is $1,563, and each unit of tops costs $10. Write the cost function C of x, where x represents the number of packets of tops produced. So it's simply put the cost function. This is a fixed cost. Each one is 10. We're going to sell X amount or produce it, X amount, 10X plus 1,560. Find the profit function. Clearly, profit by definition is revenue minus cost. So we are going to subtract the cost from the revenue. To do so, we are going to distribute the negative sign minus 10x minus 1,563, and these two combine, meaning that minus 5x squared is to give us plus 590x, and this one is itself minus 1,563. How many tubs must be produced and sold in order to maximize profit? Notice this is a quadratic function. A is negative, so it opens down. So the graph is a parabola that opens down. The maximum occurs at x equals minus b over 2a. Remember, a parabola that opens down has a maximum. X is minus b over 2a. This is a, minus 5. This is b, 590. This is c, minus 1,563. So minus b, which is 590, over 2 times a, which is 2 times negative 5. This is negative 10 with this positive, so it's simply 59 times. So how many will maximize profit? 59. What is the maximum profit? We go to the profit function and replace the x with 59. Minus 559 squared plus 590 times 59 minus 1,563, and we do the math, it becomes 15,842. What price must the company charge in order to maximize profit? In the beginning, the price function was given. Price function is minus 5x plus 600. Replace the x with 59. They add up to $305. That's how you get to the answer here. The polynomial of degree 3 p of x has a root of multiplicity 1 at x equals -6 and a root of multiplicity 2 at x equals 4. P of x passes through the point 2, 8. Here's the x coordinate, here's the y coordinate. Find a formula for P of x in factored form. Reminding everyone, what is a polynomial? Polynomial function. A polynomial function of degree n in the variable x is a function defined by P of x is a sub n, x to the power of n, plus a sub n minus 1, x to the power of n minus 1, all the way to a sub 0. Where a sub I, each one of those, is real, a sub n can't be 0, and n is a whole number. This is the leading term. A sub n is called the leading coefficient. A sub n x to the power of n is called the leading or dominating term, which ultimately the concept of n behavior depends on that. A sub 0 is called the constant, it's just a number. P of 0 is a sub 0 is the y-intercept of the graph of P. So this is a polynomial. One of the root is x equals -6. That means x, if you were to take it to the other side, becomes x plus 6 equals 0. So x plus 6 is a factor. So I want to make sure we understand what happens here. This corresponds to a factor of x plus 6. Multiplicity 1 means the exponent is 1. X equals 4 corresponds to the factor of x minus 4. In other words, x minus 4 equals 0. Multiplicity 2 means the exponent is 2. So we write exactly that. And what's in front? What is the leading coefficient? We don't know. We're going to call it something, for example, a. So a times x plus 6 to the power of 1, we don't write it. The reason it's power of 1 because multiplicity is 1. X minus 4 because x equals 4 gives you x minus 4. Multiplicity 2, that means the exponent is 2. So what is this a for? We don't know what it begins with. How do we find that? Well, we are given a pair. Replace the x with the 2, p of x or y with 8. So p of 2 means 8 times x plus 6, we replace it with 2. X minus 4, we replace it with 2, and it's supposed to be 8. Obviously, this is 8. This is -2. This is 4. Please understand, I can drop the 8 from both sides. So 4a equals 1. A is 1/4. And now we are going to write P of x is a, which is 1/4, times x plus 6 times x minus 4, 1 squared. Divide using synthetic division. Express the answer as f of x over d of x plus q sub x plus r of x over d of x. So this is the function. This is the quotient, and this is the remainder. So we want to divide these two. The way the division works when it comes to synthetic division, I'm assuming everybody remembers long division, uh, is as follows. Division of a polynomial by x minus k, for example, x minus 5, x plus 5, x minus 10, x plus 10, things of that nature. If the degree n polynomial p of x is divided by x minus k, then the quotient polynomial q of x has degree n minus 1. So because this one has degree 1 and this is being divided by it, it goes down by 1. So whatever it is, so in this case, this is 3, this is 1. The result, the quotient must be of degree 2, n minus 1. The remainder, sometimes they use capital R, sometimes they use lowercase r, is a constant and may be 0. Because this is of degree 1, then the remainder must be of degree 0. That means a constant. A complete quotient for p of x over x minus k may be written as p of x over x minus k equals q of x plus r over x minus k. So again, lowercase or uppercase, lowercase r, uppercase r. So here's the dividend as an example. 3x minus 2x plus 5. We are dividing by x minus 3 as an example of a divisor. When we go through the process, we get the quotient of 3x squared plus 9x plus 25. What's this fraction? The numerator 80 is a remainder, and the denominator is just like that one. Is still a divisor, which is the fractional part of it. So that's what we get. Now with synthetic division, here's the methodology. You put, because you're dividing by x plus 1, this, remember, this is x minus k, you put minus 1. If it's x minus 1, you put 1, and then you put these coefficients in order, has to be in descending order. Anything missing, you put a 0. So 3 minus 2, positive 1 minus 4. So we write 3, negative 2, 1 minus 4. X plus 1 gives you negative 1. Again, for example, let's say this wasn't there. You have to put a 0. This was x plus 5. You would have to put minus 5. It was x minus 10. You would put positive 10. That's how it works. You just drop the first number. The reason is 3x cubed divided by x is 3. Then you are going to multiply, whatever you get here, you multiply by this number always. So we're going to multiply it by this. That gives us negative 3. Now we add this two. We get minus 5. Again, we multiply by negative 1. We get positive 5. We add them up. We get 6. Multiply by, again, negative 1. we get -6. Add them up, we get -10. So going back to here, this is of degree 3, this is of degree 1, the result is of degree n minus 1, 2. So 3x squared minus 5x plus 6, this is the remainder. So we write it in this fashion. 3x squared minus 5x plus 6 minus 10 over x plus 1. Consider the function f of x equals 2x cubed minus 8x squared plus 5x plus 3. List all the possible rational zeros of f. So what's the theorem? Rational zeros. Factors of a sub 0, the constant. See, when f of x is a sub n x to the power n all the way to a sub 0. Factors of a sub 0, which is the constant, over factors of a sub n, which is the leading coefficient. So what do we do? Factors of a sub 0, 3 over factors of a sub n 2. So what are factors of 3? Plus minus 1, plus minus 3. What are factors of 2? Plus minus 1, plus minus 2. If you divide this, you get plus minus 1 this, plus minus 1 half this, plus minus 3 halves. This plus minus 3. So those are all possible rational zeros. What does it mean? It means if there is a rational zero, must be one of them. Again, by zero, we mean a root, a factor. So for example, if 2 is a rational zero, that means this is divisible by x minus 2. That's the meaning of it. So if we say there's a zero means that a factor, in essence, the root. So if 5 is a zero, that means this is divisible by x minus 5. So if -1 is a zero, that means it's divisible by x plus 1. So those are possible rational zeros. Are they all zeros? Absolutely not. Those are possibilities. Find the rational zeros of f. Now, what is the methodology? The methodology is that you plug in one by one, and as soon as you hit 0, okay, which is the concept of a remainder theorem, that becomes a rational zero. And then either you continue with that process, or if it's of degree 2, you can do the factoring or division. So let me explain the following now. Remainder theorem. If a polynomial p of x is divided by x minus k, in some texts they use x minus a, in some texts they use x minus c, as you saw in the previous page. I do use all of them just to let you know it depends on the text. But the concept is identical. The remainder is equal to P of K. In other words, if you plug in K into this, whatever it gives you is the remainder. Now, factor theorem says the polynomial P of X has a factor of X minus K if and only P of K is 0. So if it becomes 0, that means it's a factor. Now, you really have to check all of them, and it does take some time. I want you to know that. But that's one way to come up with the answer for a polynomial which has a degree larger than 2. So what do we do? I'm going to try number 3, and I want to make a point. It's 2 times 3 cubed minus 8 times 3 squared plus 5 times 3 plus 3. If you work it out, it ends up being 0, everybody. This is 27. This is 9. So we have 2 times 27, 54 minus 72 plus 15 plus 3. It ends up being 0. Because that is the case, one of those rational zeros is number 3, which means this function is divisible by x minus 3. We want to find the remaining zeros. So we are going to try more. Sometimes you have to try more to see if any more rational zeros. Sometimes you don't have to. And here's the reason you don't have to. This is degree 3. This is degree 1. When you divide, becomes degree 2. And quadratic functions, you can handle them either by factoring or the quadratic formula. So to divide this, again, we're going to go with the reason I want to divide it. I know it's divisible. The reason I want to divide it because I want to get the second degree function we come up with. So we are going to go with the synthetic division. We put 2 minus 8, 5, 3 in order, and number 3, because x minus 3, you go with number 3. You drop number 2. You multiply by this number. 6 and negative 8, they add up to negative 2. Again, multiplied by 3, negative 6. Add them up, negative 1. Again, multiplied by 3 and add them up becomes 0. And that's the key. It is supposed to become 0 because in essence, we showed it here. So the result is, so this was cubed. So 2x squared minus 2x minus 1. So that's pretty straightforward, everybody. So what do we do now? The next step, because this is a quadratic function, we try to factor it. We can't. We're going to go with the quadratic formula. And everybody remembers, by the way, you can calculate b squared minus 4ac and see that it doesn't work. This is something we have discussed already. So put it into the quadratic formula, minus b. Let's just write, this is a, this is b, this is c. Minus b, that means minus negative 2, plus minus the square root of b squared, negative 2 quantity squared. minus 4 times a, which is 2 times c, which is negative, divided by 2 times a, which is 2. So 2 times 2, this is 2 times 2. So this becomes 4 minus becomes plus 8 or 12, and 12 is 4 times 3. So we are dealing with 2 plus minus 2 square root of 3 divided by 4. And we can factor the 2 out. And so we get this one. So factor f using the zeros of f. Okay, so we know one of them is 3, so one factor is x minus 3. One of them is 1 plus square root of 3 divided by 2. One of them is 1 minus square root of 3 divided by 2. We write them in this fashion. So that's what we get. And we are going to move on. Consider the function f of x equals x to the power 4 plus 2x cubed plus 22x squared plus 50x minus 75. We want to find f of 1, we want to find f of negative 3, and I'm reminding you of rationals. So obviously, plug in 1. That means 1 to the power of 4, 2 times 1 cubed, 22 times 1 squared, plus 50 minus 75. And this becomes 1 plus 2 plus 22 plus 50 minus 75. They add up to 0. F of negative 3, I leave it for you to evaluate it and verify that is also 0, everybody. If you plug in negative 3, you get 0. So f of 1 is 0. So is f of negative 3. if we were to use rational zero theorem, would be factors of negative 75, which is the constant, over factors of 1, and of course, factors of 1 are plus minus 1. So just factors of minus 75, which is plus minus, by the way. Plus minus 1, plus minus 1, 3, plus minus 5, all the way to plus minus 75. And you have to check it out. If you were to do that. Also, if you want to use the technology, you can graph it, use second calc, 0, or try these numbers one by one. By that, I mean these numbers, okay? You can find this function and plug in those numbers. As far as the technology is concerned, that's how it works. You can do this pretty fast. Now, we're going to continue. So we have two zeros. One of them is 1, one of them is minus 3. Now, if 5I is a zero of the function, find the remaining zeros of f. Of course, we have a theorem that says number of zeros theorem. A function defined by a polynomial of degree n has at most n distinct, unique, complex zeros. Remember, complex zeros are in the form of a plus bi. And conjugate zero theorem says if p of x is a polynomial with real coefficients and if r equals a plus bi, one of the roots is a plus bi, is a zero of p of x, then its conjugate r bar a minus bi is also a zero of p of x. That is called the conjugate zero theorem, everybody. Therefore, if 5i is given as a zero, its conjugate, which is minus 5i, is also a zero. This is purely imaginary class. Let's say it was 2 plus 5i, it would become 2 minus 5. So be careful with that. Factor f of x using the zeros of f. Well, this means x minus 1. This means x plus 3. This means x minus 5i. This means x plus 5i. We write them all together. Now, these two, if you recall, a minus bi times a plus bi is a squared plus b squared. So x squared plus 25. Again, I'm going to put them up here, reminding you a minus bi times a plus bi is a squared plus b squared. So I hope everybody remembers that and everybody appreciates that. All right, we are going to move on. Find the domain of the following function. Express your answer in interval notation. F of x is x squared minus 4 over x squared minus 2x minus. As you recall, when you want to find the domain of a rational function, you set the denominator equal to 0 and you exclude them. X squared minus 2x minus 8 equal to 0. You want two numbers. The product is minus 8. The sum is negative 2. The answers would be 2 and negative 4. When you set this equal to 0, this gives you negative 2. This gives you positive 4. These are the two answers that must be excluded. So one easy way is to write the domain x such that x is not negative 2, x is not 4. But with the interval notation is what we want to do. And we are going to write negative infinity to negative 2 union, negative 2 to 4 union 4 to infinity. All of them take parentheses. And I want you to pay attention to the parentheses. First of all, negative and positive infinity, they will always get parentheses because they are concepts rather than numbers. Now, because we are excluding negative 2 and 4, parentheses means exclude them. Bracket means it's included. So you use parentheses around negative 2 as well as 4. Use the remainder theorem to evaluate this function at x equals 2. Plug in. According to the remainder theorem, all you have to do, plug in everybody. So replace the x with whatever is given, in this case 2. Of course, 2 to the power 4 is 16, 2 cubed is 8, 2 squared is 4, you plug in. So 6 times 16 minus 8 minus 15 times 4 plus 4 minus 7. You do the math, this is 96 minus 8 minus 60 plus 4 minus 7 equals 25. So you just do some basic math. It's really not a big deal, everybody. Show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. After that, find the remaining factors. Then use the factors to determine the zeros of the polynomial. So first and foremost, if you want to show this is a factor, one easy way is to use the factor theorem. So you got to plug in negative 2. If this is divisible by this, that means f of negative 2 must be 0. We're going to call this f of x. Negative 2 cubed minus 6 times negative 2 squared minus minus 2 plus 30. So minus 8, positive 4 times negative 6, negative 24 plus 4 plus 2 plus 30. So we have minus 8 minus 24, which is minus 32 plus 32 is 0. So we proved x plus 2 is a factor. So we can quickly divide this one by this one. And because this is degree 3, this is degree 1, the result will be degree 2 or quadratic. And then we can do either factoring or the quadratic formula. So we are going to do the synthetic division. We're going to write 1 minus 6 minus 130. Again, nothing is missing. If any of them is missing, you have to put a 0 as a placeholder. Dividing by negative 2, 1 drops. Then you multiply it by negative 2. You add it to this one, you get negative 8, and you continue. So I'm going to assume everybody can easily finish that. So what does it mean? It means 1 x squared, or simply x squared, minus 8x plus 15. So this is the product of x plus 2 and what I just mentioned. So we write x cubed minus 6x squared minus x plus 30 is x plus 2, and then times this x squared minus 8x plus 15. This we can easily factor. We want two numbers. The product is 15. The sum is negative 8, negative 3, and negative 5. So x plus 2 times x minus 3 times x minus 5. So we have factored this into x plus 2 times x minus 3 times x minus 5. So what are the zeros? The zeros are negative 2, positive 3, positive 5. So by the factor theorem, the zeros of x cubed minus 6x squared minus x plus 30, f of x, if you will, are negative 2, positive 3, positive 5. Given the function f of x equals x plus 4 over 2x squared plus 11x plus 12, find the domain of f in interval notation. Anytime you have a rational function, in order to find the domain, you set the denominator equal to 0 and you exclude that, and to do so, you're going to factor. The factoring actually is fairly simple because here's the denominator, everybody. This says you have to go with x and 2x because 2 is a prime number. Then you work on 12, and again, if it can be done, 1 and 12, 2 and 6, 3 and 4. If you want to go with the trial and error, there are other ways. You have to choose one of them such that the middle term works, and it ends up being 4 and 3 because this is 8x, this is 3x, and they do add up to 11x. Okay, I'm going to clean up my mess. Although we drop these two, it's important the way we write it. We write f of x is the same as this function, 1 over 2x plus 3, yet x can't be negative 4. Which means, as far as the domain is concerned, originally x can't be negative 4, and it continues to be. So there are two numbers x cannot be. One of them is negative 4. One of them is negative 3 halves. So we write the domain as, okay, these are the two numbers that they can't be. So from negative infinity to negative 4, union negative 4 to negative 3 halves, union negative 3 halves to infinity. That becomes the domain. Again, let me erase my work. Find the asymptotes of f of x. We are dealing with graphing. Therefore, it's a rational function. We are looking into asymptotes. Now, how do we find the asymptotes? Well, we have the vertical asymptotes, horizontal asymptotes, slant asymptotes. So it's important to know you can't say here, set the denominator equal to 0, x equals negative 4, x equals negative 3 halves. That's not how it works. You have to look at the simplified version. So what happens at x equals negative 4? If you plug it in here, this is the location of a hole. So how do we get a hole? If there is a common factor between the top and the bottom equal to 0 is not the asymptote. You can't do that. Rather, you cross it out, but at x equals minus 4, it creates a hole. How do you find the y coordinate? You plug it into this function, the simplified version. So there is a hole at negative 4 and plug it in 1 over 2 times negative 4, which is negative 8 plus 3, which is negative 5. So at negative 4 comma negative 1/5, we have a hole, everybody. We don't have a vertical asymptote. So again, this may not be to scale, but minus 4, this is 1, 2, 3, 4 to the left, and this is 1 down. Okay, so roughly here. By the way, the scale along the x and y may or may not be the same. Okay. Now this one, the simplified version, if you set the denominator equal to 0, becomes a vertical asymptote. So when you set this one equal to 0, x becomes negative 3 halves. That's VA, short for vertical asymptote. So vertical asymptote, set the denominator equal to 0. What about horizontal asymptote? So this is vertical asymptote, x equals negative 3 halves. It's a vertical line. What about horizontal asymptotes? Given a rational function of n of x over d of x, f of x is n of x over d of x. The numerator is a sub n x to the power of n all the way to a sub 0, and the denominator is b sub m all the way, b sub m x to the power of m to b sub 0. The degree for the top is n, the degree for the bottom is m. If n is less than m, the horizontal asymptote y equal to 0. This one, the degree, the numerator has a number only, the degree is 0. The bottom is 1, so it has a horizontal asymptote y equals 0. If n is equal to m, then you just divide their leading coefficients. If n is precisely m plus 1, so the degree is lower, the degree is identical a sub n over b sub n. It's larger, but larger by 1 only, you divide, and the quotient y equals mx plus b becomes slant or oblique asymptote. So the horizontal asymptote y equal to 0, there is no oblique asymptote because you either have this or that. So that's the same. Remember, y equals 0 is the x-axis, x equals 0 is the y-axis. Find the intercepts. That means set x equal to 0, find y, set y equal to 0, find x. Okay. So if we set x equal to 0, we get 1/3, so 0, 1/3. If we set y equal to 0, a fraction is 0 when the top is 0. The top is a number. Doesn't matter, positive, negative, or large or small. There is no x-intercept. So x-intercept none, y-intercept 0, 1/3. Let me quickly recap. If you set x equal to 0 here, you get 1/3. That's your y-intercept. If you set y or f of x equal to 0, it can't happen because the fraction is 0 when the numerator is 0. So we plot this one. Roughly, it may not be exact. This is your y-axis. This is your x-axis. So roughly 0, 1/3 is here. Locate at least 1 point on each side near the vertical asymptote. So what happens is, class, when you have a vertical asymptote, it cuts it into subintervals. Since we have 1, 2 subintervals. If we had 2, we would have 3 subintervals. So on the right side, we want 1. On the left side, we want 1. And we already have 1 on the right side. Remember, you're dealing with a rational function, and it has to go through this one. So it goes like that or like that, but not both. Okay. So to the left of this, because this is negative 3/2, we can go with negative 2 and come up with the answer. If I plug in negative 2, I get negative 4. Plus 3, negative 1. 1 over negative 1 is negative 1. If I want another point and I put on the right side of that, for example, I put negative 1, then it becomes negative 2 and 3 is positive 1 becomes 1. So I hope you see if I put negative 2 in here, I get negative 1. That's my pair. If I put negative 1 in here, that's my pair. So I have those two, and here's the graph. Here's the graph. Okay, sketch the graph, label the intercepts, asymptotes, and any holes. So those are the ones. What I want to add before I look at the last question is the following. Again, your vertical asymptote gives you two subintervals. You can't have another piece here, otherwise it's not a function. You can't have another piece here, otherwise it's not a function. Number one. Number two, what is the difference between this function and this function? This function doesn't have a hole. This function, because you cross the x plus 4, is identical to this function, except at this point it has a hole. One more time, this is important. If we had this function to graph, we wouldn't have a hole. Everything will be what you see. But since we have this function, we have to cross out the common factor of x plus 4, creates x can't be negative 4, results in a hole. I'm going to repeat the concept with a different function. Given that f of x is x plus 1 times x minus 5 over x minus 3, find the domain of f of course, in interval notation. And so what we are going to do, clearly x can't be 3. So you write negative infinity to 3 union 3 to infinity. Find the asymptotes of f of x as well as any wholes. If there is a common factor, there is a whole. So this one class, there is no whole when there is no common factor. Vertical asymptote, x minus 3 equal to 0. Horizontal asymptote, none. Why not? Well, the degree of the numerator is 2, the degree of the denominator is 1, and it's larger, therefore there is no horizontal asymptote. I hope you see this 2 gives you x squared, 1 and minus 5 is negative 4x, and 1 times negative 5 is minus 5. So this is your vertical asymptote, x equals 3. This is your function. You have to divide. And I'm going to leave it for you to do that. It becomes x minus 1 minus 8 over x minus 3. So you do the division by any means. For example, the synthetic division. You get x minus 1 minus 8 over x minus 3, which gives rise to the slant asymptote y equals the quotient x minus 1. There, and there is no hole. As I mentioned, I told you there is no hole, and why there is no hole. So now we are going to graph y equals x minus 1, 0 minus 1, 1, 0, and it looks like that. Y equals x minus 1. Please understand, if I put 1, I get 0. If I put 0, I get negative 1. And again, they may not be two scales. So basically, you have two pieces. Either one is here, and the second one is here. One is here, or the second one here. Normally, they are the opposite, because if you have a piece here and you have a piece here, it won't be a function. That's why. Find the intercepts. X is 0, find y. Y is 0, find x. Well, the x-intercept obviously is looking at you. You set the numerator equal to 0, you get minus 1 and positive 5. That means minus 1, comma 0, and 5, comma 0. So n over d, n equal to 0 when you want to find the x-intercepts, the numerator is 0. And with that being the case, this gives you negative 1 again, as I said, negative 1, 0. This gives you 5, 5, 0. And so you locate those, negative 1, 0, 5, 0. The y-intercept, it's easier to go with this one, 0 here. So you get minus 5 over minus 3. Minus 5 over minus 3. The answer is 5/3. 0, 5/3 is located. And I hope you see that. You want to graph it. It says locate at least 1 point on each side, and so on, and so forth. Here's your vertical asymptote. On this side, I have 1 point, so that would be the graph. On this side, I have 2 points, that would be the graph. So I don't need more points, and that's the final answer.